Hello, can you hear me?
Yes.
Okay, since this one is a free version, it's cut every 40 minutes because of the recording. Every 40 minutes, it will cut off. And we have to establish a new meeting every 40 minutes because it's a free version. Anyway, let's go back very quick to that. So what's the block model exactly? As you can see over here, and as we discussed, that I put my services into different blocks. For example, block responsible for the server in one area, another mainframe in one area, the WAN block in one area, the core block in one area, and the distribution and the building link to as well into a blocks. Okay, so what the block model exactly involved in? Are you familiar with SDLC? Have you heard about something called SDLC? Okay, if you haven't heard whatever, that's some kind of phases. You design, then you implement, you evaluate, you operate, you evaluate, and then again. What exactly? We have three phases over here in how to building blocks design. To analyze, the technology design, and then after that, the cost assessment. This is what we cover, by the way, for the rest of the lecture for today. It's easy, by the way, don't get me wrong, that's almost like blah, blah, blah only. So what we will cover here, this is the phase, which is the need analysis phase. What's involved exactly? The baseline. What is the baseline exactly? What's the current operation? What's your current situation? Most of the network you build, by the way, you didn't build any network from scratch, unless if it's a new company or something like that, which I believe that not too many. But most of the over 95% or 90-some% of the network you work on, you have a network already and you want to upgrade or you want to improve, but you didn't start from scratch. So the baseline exactly like this. What's your current situation right now in terms of hardware, software, applications, and users? The geographical scope, what is that? Is that LAN or MAN or WAN? How far, how big that network will cover? The application system, what kind of application system what application you use, and how it's been distributed. What type of users you actually using? What kind of users do you use? They using your network. They are professional or non-professional. They are heavy traffic user or heavy bandwidth user or moderate user, and so on and so on. You need to identify your user and the needs. And the last piece for that in analysis, what we call it categorize or classification. Traffic or network bandwidth, and user classification. Or in short, priority. You have priority over your network. I asked you before, if you are a router and you have a few packets come to you, one of them audio, one video, one email, one FTP, one network management, for example, which one you will process first? You have to have priorities. You cannot treat everybody equally. Why is that? If you have packets, if you have a video conference or audio, for example, you're making a call online, you don't want someone to cut you off to pass an email. The email can delay. Few milliseconds in delay in email will not hurt, but few milliseconds in voice, it will hurt. You will not understand what the other side try to say or try to do. So what we call that classification or categorization or priority. So remember that the need to categorize means the need to classify your data. Client and server circuit, which is the cable, the link between the devices in terms of LAN or MAN or WAN. And this one, the last piece, which is the cost assessment. How the total cost will include hardware, software, license, and operational. And the last piece we will cover today, the request for proposal. And if you work in any company, you will come to that. What is that exactly? Let's go over one by one very quick and see what's that exactly. The need analysis. If you want to analyze what's that to analyze. The first thing you need to ask, what this network for? Yeah, what type of network is that? I'm gonna provide what that network will provide. Provide email or video or audio or what kind of services? IS service, IT services, customer services, whatever. What kind of service you will provide? What that network for? What kind of user they use? What kind of customer they will be? What kind of application you will need? You need to define to analyze everything, including the links and the circuits. You start with the baseline. The baseline means you start running what your system right now, what the system I have right now, what you got, what kind of server you have, what kind of links you have, what kind of department you have, users, everything, applications, hardware, software. Analyze everything. And after you have analyzed that, you will come to term that I need to upgrade in some areas, I need to change in some areas. And also, when you design that, you try or to analyze that, you make sure that to have in your mind that what's gonna be after 5 years, how it look like after 10 years, what about after 15 years, after 20 years, how that network will look like in 10, in 5, in 10, in 20 years. And always prepare for expansion. Always prepare for expansion. We have, in week 1 and 2, we explained the word scalability. And if anybody still remember what scalability exactly, the ability to increase, expand, or shrink without restructuring. The objective of the need to analyze, you need to analyze everything and find out what exactly your actual situation right now with your network. And after that, you need to come up with the ideas that what I need to add, change, or improve, and give me a view of the next 5 years, 10 years, 15 years, 20 years, how the system will be look like. At this stage, you do not need to specify any type of hardware or software, just general ideas. What my um, network situation look like right now. This is the breakdown into the system into three layers as the access layer, which is this one, the one close to the user, the distribution layer, the high speed access, which is the layer. This is the most intense distributed bandwidth between, and then over there the core layer, which has the main servers and the main applications. What you need exactly over here, let me just give you my what to do exactly if you want to design a network. The first thing we need after you analyze the network, you need to specify is this one LAN or MAN or LAN, MAN or WAN, and which area, how geographical, how big that will be. So, for example, if this is a WAN, okay, so now I have a branch in Sydney, another branch in New York, another branch in Germany. What to do exactly? You need to specify. Right now I have a WAN. Okay, what kind of technology I'm gonna link those one together? How I'm gonna link them together? Through the WAN, for example, through the internet or through what kind of link I'm gonna use? I'm gonna use what? Now, fiber optic. I'm gonna take a T1 cable, which is lease cable. I'm gonna T1, for example, or fiber optic, or whatever you want. Just we have many options here, and you can actually have lease link or lease circuits. What is that exactly? You pay for the ISP provider. This is the ISP, whatever the ISP is. The ISP will provide you with different options, and each option has a pay. You need to pay for that. Okay, you need to specify that first. All right, now I link those ones together. The second stage, what you do exactly, you take, for example, this is Sydney. All right, how Sydney will look like? Is that one building or multi-building? For example, this one is one building. All right, the building over here. This is my building. And from here, this is the, for example, that's the router going to the building. Over here, you need to specify the building here. Okay, how many floors, for example, and which department is going to be. For example, this is the IT department or the developer. This is the developer. You need to specify over here what user inside and how much link or bandwidth they need. For example, the developer, they need high level of bandwidth. So what to do exactly? I need to provide them with some type of cables and connections which can provide them with high level of connection or bandwidth. What about the human resource? The human resource doesn't need any much traffic. All right, just provide them with something which is enough for them. What about if I have someone else who is actually here accounting, which is mild user? All right, provide them with a mild user link. However, we actually recommend you to have within the building, if you have one type of cable, use the same link, the maximum one, the top one. For example, if you're using fiber optic into the building, even those ones using less bandwidth try to provide all of them with the same type of link. Why you may in the future changing that department from this location, for example, move them to another location and put another developer over here. You may, something like that. In short, put classification over here inside the building, and that's what it is. Inside here, what I need, you need to specify what kind of computers, what kind of servers, what kind of links, whatever, applications. For example, developer, what they need software, type of software, Visual Studio, they need Oracle, they need whatever. I need to specify everything for each department, what they need, and I will run what we call simulator later on to see how the traffic works. You need to do that between this building and that building and that building as well. However, when you start from the top first. It is geographical scope first. This is the first thing to do. After you finish the geographical scope, you move to the what kind of link you're gonna link them together. After that, take branch per branch, building per building, or country per country, like that. From the top to the bottom, in short. What kind of constraints? Constraints means limits. What type of constraints exactly we need? Technical constraints. What is that? For example, if I have a LAN, I don't need T1. If I have a LAN like this, this is LAN. In one building or couple building or a small geographical location. Do I need T1 link? I don't. They are in a small geographical location. This is WAN link. So as far as like I'm gonna use, this is LAN, I don't need T1 link, right? Constraints imposed by the current network. What is that exactly? If I'm using cable here, if I'm using one type of cable here, and I want to extend, for example, another building like here, this is the developer, and they use, for example, fiber optic. And I'm going to expand another department. We prefer to use the same cable. Do not use different type of cables or circuits. Use the same one. The design process starts from the top to the bottom, as we mentioned, like this. And I get you this samples, just only. As you can see over here, you have 3 different locations. Each one represents LAN, and connected by the internet. And this one, as you can see here, the serial links, those ones can be different type of links, which is between 2-1 until you get fiber optic if you want to. The application system. And this is really actually an important one. What type of application you actually running inside your system? Because each application requires different bandwidth, and this is you need to keep in mind. Applications, for example, if I'm running Oracle server and I'm running or SQL server in the top of another application, this type of application usually SQL and Oracle, they require high level of bandwidth. So you need to understand what's in that area, what's in that location, so I can provide them with enough bandwidth. Designing a network without understanding what application we're running in this area or this department, what kind of user here and what they will need, and just designing like this, it will have, after you implemented the design, you will have a lot of problems. You need to understand the user, the application they run, and what kind of bandwidth they use. Identify the software and the hardware requirement, what kind of users you need to you work on, if they are heavy user or light user or moderate user. First, categorize or classify your data. By the way, you need to classify your user and your application. Classify your user, your geographical areas or department, and you need to classify it as well the application in terms of priority. One of the priority, which is we put it as high priority or moderate priority or low priority, or what we call it mandatory or desirable or wish list. What is that exactly? Just let me give you an example. You have a building like this. It's a sample of building. The building has 3 floors. I have here department, east, west, whatever it is. Inside that building, for example, I need to classify something as high priority or mandatory. What is that exactly? The servers. If I don't have servers, not so what I'm doing. If I don't have right now Canvas, for example, the Canvas server, what's the point of trying to log in? There's nothing. Email servers, web servers, SQL server, whatever the server is, we classify those ones as mandatory, something it has to run 24/7. Okay, the moderate one, you can put anything in the middle. For example, if I have a simulator software, packet tracer, whatever application, something like that in one of the servers, and you want to run it, maybe not, it's okay. Moderate, it's work, yes, not high priority. Low priority or the wish list, something like if I want to have something like a video conference room or something like that, maybe not, wish list in the future. If I have it, yes. If I don't have it, it's okay. The technology design, which is you need to, this one mostly you're involved in term of what type of network structure you will use. And we mentioned before that mostly we will use client server architect, network architect. And inside that, you need to specify what kind of client, what kind of servers. The client means the customers. For example, in EPIC, as an EPIC college, what we have exactly, we have students, that's our client. And we have another user, the admin or the lecturer, whatever, that's how it is. Inside that, we need to specify what you guys need, what the students need actually, what kind of application they use, what server they use. They need email server, they need the Canvas server, the RTO server, you need the Canvas, you need the email server as well so you can communicate. That's what we need to specify that. For us as a lecturer or the admin, we have a little bit extra, okay, some applications, yes, but it's still the same concept. Then we specify over here how to connect to the outside, which is usually involve the gateway, the routers and the gateways from here. How to connect from my building to over here to the outside world. Designing client and servers, if it's high volume, low volume, the links between if it's LAN or MAN or WAN, and that's really important. If your network only inside one geographical area or small inside the city, how I link Sydney CBD, for example, to Central, if I have 2 buildings, like Epic College, for example, or the VU, or whatever. How to link those together? Small geographical area, that's MAN, yes, I can link them with different type of connections involved with T1, ADSL, fiber optic, or I can use wireless if there is no obstacle in the middle. However, that's what type of link you will use between. That's if they are in the same city. If they are in different city, you need to use what kind of link you will use. One in Sydney, one in Canberra, how are you going to link them together with what T1, ADSL, fiber, whatever you will link. But if each one has different cost, by the way, and you need to pay for each one. Estimate the circuit traffic. How to do that, by the way, one of the things which is, I just want you to make sure that about that, what to do exactly with the estimate traffic. Usually when you have, you work in a company or the government, whatever, you work from 9 to 5. So we have what we call peak time or peak use. What is the peak use? 9 o'clock, between usually 8:45 until almost 10 o'clock. This is the peak. This is everybody try to log into the system. You're running your application, you're running whatever, you're downloading software, you're running everything. This is very peak time. And then we have slow time, which is from 11:30 until 1 o'clock. Then another little bit peak, then slow from 4 o'clock until 5, something like that. Okay, so how to estimate the traffic? We cannot take precise actual traffic or bandwidth. We have capacity, yes, but we have average traffic. What is average traffic? I have here 100, then I have here 60. What about here in that time? 40, you put them together, divided by 3 or something like that, you get the average of the bandwidth. But not, I cannot estimate the bandwidth all the time as 100. There's no way. So it has to be average. We have peak traffic, average traffic. You need to estimate that. And sure, you need to be, we don't have a precise, accurate 100% traffic. You need to design your traffic to hit higher than what the peak. For example, if the peak traffic is 80, I need to have 90, I need to have 95, and so on. The capacity overbuilding, which is that's what one of the issue with the traditional network design. What's the problem with the traditional network design? You try to build a system. If you didn't plan for expansion or shrinking. So what you do exactly? You build something to, let's say, to suit 100 people. Then you actually only has 20 people. All right. So you actually overbuilt something. What about if I built for 20 and I came to expansion? I need to add 200 people. You cannot because you have traditional network. So you need to redesign again for 200. And that's how it is. Usually for when you design something in layer, usually we leave when you design. For example, I'm designing right now something for 400 students. For example, include the admin, include the lecturer and everybody. When I design, I need to add at least 10% extra. So when I design for 440, 460 minimum. Some companies, they prefer to have 20% extra, but that has to be minimum of 10% in everything. 10% of all the resources you have, computer, software, everything. So you always think about what you will do in the future. How to do, by the way, what to do exactly? We have what we call it software simulation. What you see in Packet Tracer or other software, it didn't generate actual system. We have software which called Riverbed, for example. A lot of software which is Riverbed, for example. What is one of the software? You build a network like that. For example, you design your own network. Whatever the network is, 10 minutes. Okay, we will finish in less than 10 minutes. You design your network, and you want to make sure that it's work perfect. You cannot go after you design the network on papers and everything, and you design everything. Now you need to make sure before you propose it to your boss that it's working fine. What to do exactly? We have simulators. One of the software, which is called Riverbed Simulator as well, you have heaps, by the way, but you can use something like that. What to do exactly? I build exactly the same network I have, and you can pick the same cable you will use between routers, what model of routers, what bandwidth you will run here, whatever is here. Then after that, you start generating traffic similar to the traffic the user will use. In short, you have a real running simulation for your network. And at that time, when you run the network in average time, in peak time, you will you will find some errors. What is the problem here in my system? Is it here or here? And you will find, for example, you generate traffic from this user to the server. That link cannot actually, it has bottleneck over here because it cannot run whatever. Or that switch over here, you generating too much traffic here. It can the switch, this type of switch cannot take it. So you need to replace that. In short, after you design your network, you need to put it in a simulator first, and you run that simulator to make sure that everything running professional and perfect before you actually put it into final stage to the paper and you put it for proposal. That's what we call it simulators. We have plenty of simulators. Feel free to pick any one. This is the physical design, and again, I'm going to show you a very quick one. When you have a building like this, what we prefer to do, by the way, just remember that this is floor number here, and this is your for example, this is your room. This is the router, the main router, come from the ISP. When it's arrived over here, what we prefer to do exactly, we prefer to have a layer 3 switch, which is high speed one, layer 3 switch. Out of that layer 3 switch, running cables. What is that exactly? This is layer 2, or layer 2. From this one, connect here, here, and here. Layer 3 switch has high level of bandwidth compared to layer 2. So if you have, for example, if you have a big building and you have many employees here, what we prefer to have, this is layer 3, I'm gonna put over here layer 3 as well, layer 3 as well, layer 3 as well, and connect them with this one, connect them with this one, connect them with this one, directly to the ground floor. And from here, I can take to lab number 1, for example, layer 2 switch. Lab number 3, layer 2 switch. And so on and so on, each floor. The cables run from layer 3 switch to the top layer 3 switch. As well, we prefer to have high bandwidth, like fiber optic or so. You can see something like this, for example. As you can see, this is the main router. I have layer 3 switch here, and that's layer 2, layer 2, layer 2, oh, layer 3. Why we have layer 3 over here, or layer whatever? Why I have something like that? That's 1 gig bandwidth switch. This is 100 base only. This is 1 gig router. Why we have here high level switch here? Because, for example, this department or this area developer, and they need high level of bandwidth. That's what we actually prefer to do that, something like that. The cost assessment, I believe that the cost involved software, hardware, applications, cables, UPS, NICs, servers, everything involved. However, don't forget the license and the maintenance or the operational, because those ones actually, or repairs, maintenance as well. Operational, maintenance, and the cost of license, really high number compared to the hardware. Request for proposal, after you finish everything, you put this one into a paper, we'll call it request for proposal, and you try to provide it into your boss. When you try to provide it to your boss, what to do exactly? Do make your proposal simple. Do not mention any technical word. For example, do not tell him that layer 3 switch with the cable 100 whatever, 100 phase, 100 whatever, that is going to create bandwidth. Your boss mostly doesn't know anything about IT. So what you come to, try to make it look like this. We will spend that money right now, but it will save me this in the next 5, 6, 10 years. So in short, we will get that money saved in the next 5 years, for example. And it's gonna give me that benefit, 1, 2, 3, 4. That's how it is. Especially in terms of money. If I spend, for example, 100 grand right now on that system will save me 20 grand every year or 30 grand every year. We will get paid back on this 100 grand in 3 years only. And after that, we're making money from that. So at that time, your boss will listen. When you put in your proposal, just put what our system right now have, what I need in the term of networking, the requirement, what kind of services we need to provide, and then after that, what you do exactly, what we call bidding process. What is that exactly? I design some network, I need a company to implement that. You contact IBM, you contact Dell, you contact Oracle, you contact multi-company, and you tell them that this is this is the system I want to build. Can you give me a code? What exactly request for a code? So what they do exactly, including maintenance, including services, including repairs, and that's what we call multi-vendor selections, codes. So what they do exactly, they send you, they take like few days, few weeks, and they come back to you with a professional code, which involve everything. What kind of servers will we use? What kind of cable? What kind of this? What kind of that? And how long it take them to implement that as well? And what's the license involved? What's the long-term cost? What's the consequences, the penalties, if whatever it is? And actually, at that time, you pick the one you like, not you, but your boss. You take it, you took those codes, and you go to your boss, and you actually explain to him which one you actually want to go with and why the reason for. So why is that? You need to speak their own language. What is language they understand? Your boss doesn't understand anything about IT. You need to speak his own language. What is his own language? The money. So here it is. This is our services. I got this code from here. If we implemented this one, it will cost us for this years. However, in 4, 5 years, 10 years, whatever it is, we will make profit from that system 1, 2, 3, 4. That time you implement everything and you explain to him that in terms of redundancy, reliable, resilient, backup, recovery, security, and everything. Implement something in simple term to your boss. And at that time, your boss will have his choices. Pick whatever the choice he will pick. That's the mostly about the block model for today. Any question? Since we have only 1 minute and they will cut it off. Any question? Any questions? Any question? Can you hear me?